The endless studier badge, you have that?
Yeah, definitely not.
Okay, whatever you say.
But it's wrong. It's silver badge, so
You're nothing. You're a 60.
All right, let's get our notes out. Yesterday, we left off, we didn't have much time yesterday. We left off with this problem. This is on page 22, number 5. And what I need is for somebody to tell me, what do I do?
Factor.
Factor it. And how does this factor? Remember, we're
X
practicing our
minus 4,
factoring.
X minus 3.
Would you say minus 4?
Minus 3.
Minus 3.
Yeah.
You are absolutely correct. You can just leave that one. All right, and then what? What happens next? That is exactly right for the first step.
Plot the 4 and the 3.
Now we draw our number line, and we put a 3 and a 4, and they have to go on in that order because that's a number line. And then what?
You shade in.
Shade in the dots because it is an or equal to problem.
Yep.
And then what?
Shade on the outside.
Shade on the outside. And why can I shade on the outside?
Because it's greater than.
That's my shortcut, right? It's a greater than. 2 dots and a greater than means it shades on the outside.
Yeah.
As long as I don't have a squared up here, right?
Mm-hmm.
That's the key. No squares, shade on the outside. Then I write my answer. Negative infinity to 3. Remember, there's always parentheses on the infinities, and there's always brackets if the dots are closed on the numbers. So there it is. There's your answer. Okay? All right, friends, let's look at the next one. We had one of these yesterday. I don't know if you remember it or not. But we had to factor by grouping.
Yep. Take out the x squared first one.
Okay?
And the 8. I don't know if that. I don't think that works out.
I don't think that works out,
Yeah.
right? What in the world do I do? I know I have to factor because I gotta get dots on the number line. There'll be 3 of them. They'll be closed in. I gotta find them. How am I gonna do this? Can't use the quadratic formula because it's not a quadratic. It has to be an x squared equation.
Could you?
Synthetic division.
Oh, goodness.
Yeah, we don't have any choice. We have to factor this thing. It doesn't group. So we're gonna think about our PRRs, which are factors of 6 over 1, and we're gonna just start guessing. So pick one. 2. Uh-oh, this doesn't happen very often, but 2 didn't work. So we'll, -2, somebody said, let's try -2. Oh, there you go, there you got it. Now, the fact that -2 worked means one of your dots is gonna be at -2. Now, I don't know which one yet because I don't know what the other ones are, but one of them's gonna be at -2. Okay? Now I need the other 2. Where will they come from? This guy right here, clear down at the bottom, that's gonna be x squared minus 4x plus 3.
Yep.
And how does that factor?
-3.
-3, -1, which means the dots are gonna be at 1 and 3 and -2. So this one's -2, this one's 1, and this one's 3. I'm gonna get this out of here. So remember, the first dot is gonna happen where that number that you divided and got 0. So for us, that was -2. Then we got a 1 and a 3, so there they are. Now, there's 3 dots. So there's no inside and outside, no more of that. I'm gonna have to pick a number. Only 1 this time. We talked about this earlier. I'll show you what happens. Let's pick one. Pick a number that's not a dot. 2? 2's right in here. We're picking 2. Right?
Yeah.
Alright, let's plug it in. 2 cubed is 8. 2 squared is 4. Times 2 is also 8. 2 times 5 and 6. Now, add all that up. Does the answer, I put in 2 here for all of those. If I add all that up, does it come out to be less than 0?
Yeah.
Yes.
That means I shade where the 2 is. You decided to pick 2, that was fine. 2 ended up working, giving us a less than 0 number. So I shade where the 2 is on the number line. Now here's the beautiful thing. There are no squares. None of my roots, none of my answers came out twice. I got a 2, a 1, and a 3. That's it. Or -2, 1 and 3. That means that my shading will alternate. Do you remember that from before? If it shades in this section, then it won't shade here, but it will shade here. If it shades here, it won't shade there. The shading goes every other section as long as there's no squares. Remember, if there's any squares in the problem, any factor squared, you have to do what we did here with every section. But if no roots repeat, then you can use your shortcut. So what's my answer? Negative infinity to -2. And then 1 to 3. And notice I'm using brackets because those dots were colored in. Is that okay with everyone?
Yes.
All right, let's look at the next one. Oh man, are we gonna have to do the same thing? We could if we really wanted to, but this one will group.
Yeah.
So taking out an x squared, what am I gonna take out of these?
-4.
-4, and that leaves me with x plus 3 because I took out the negative. We've done so many difference of squares, I'm just rolling through that. X squared minus 4 is x plus 2, x minus 2. Now, do I have any squares on my factors? Anything repeated? It's beautiful, easy problem. Where are my dots?
2, -2, and -3.
Yep, I put, gotta be in order, so -3, -2 and 2,
Yes, ma'am.
and they're open dots. Now, I know that my shading is gonna go every other one. I just don't know how to get that ball rolling. So remember, what did I do over there?
Pick the number.
Pick a number, so pick a number that's not a dot, can't pick a dot, pick any other number.
One.
One is in here. You picked one is in here. So you can go back to the beginning, which is what I did over there, or you can put it in your factors, whatever's easiest for you. 1 plus 2 is 3. 1 minus 2 is negative 1. And 1 plus 3 is 4. I'm plugging it in my factors this time. You can also plug it in up here. 3 times negative 1 times 4. Is that bigger than 0? Nope. So that means don't shade it. And if you're not shading that one, you will shade this one. And you will shade this one. And you won't shade that one. So your answer is negative 3 to negative 2. That's this section. Or 2 to infinity. Are you guys pretty easy?
Easy.
The only time they're hard is when you have a square in there, 'cause that's so much more work.
Like for this one, when we had when we had the group, would there ever be a time where they don't match?
If they don't, yeah, that happened on this problem. If they don't match, then you can't group and you're gonna have to do the guessing, right? Okay? They have to match. To do this process, they have to. If that won't work, then you have to do this process. Number 8 looks different, but we're gonna do it exactly the same way. So I'm gonna draw a number line, and I'm gonna put 2 open dots on the number line. Take a wild guess where the open dots are. Negative 1 and 3.
Why is it opposite?
It is opposite,
No, I was asking why.
because these are like parentheses. We don't need parentheses, because there's only one thing on top and one thing on the bottom. But if there was something else in there, they'd have to be in parentheses. Any guesses where I'm gonna shade?
In the middle.
In the middle, and why am I shading in the middle?
It's less than.
Because it's less than. Rules don't change, guys. So negative 1 and 3, there we go. Wow, look at number 9.
Four of them.
We're going to factor. And when we factor, we're going to have a bunch of stuff. They're the difference of squares. So how many dots am I gonna have on my number line? 4. And where will those dots be?
Negative 3.
Negative 3, negative 2, 2 and 3. Your answer won't be right if you don't get those in the right order. So make sure this is a number line. The way you count them is how they go on there. Now there's too many dots. I can't do the old inside-outside thing. So what do I do when I have all these dots? Pick one, pick a number, right? And I'm gonna pick any number that's not a dot. So you got any suggestions?
One.
One is in here. Make sure you are paying attention to where your number is. Would everybody agree 1 is in here? So I'm gonna put 1 in, and I can put it in the original. Might be easier this time to put it in the original. What's 1 minus 9? Negative 8. And what's 1 minus 4? Negative 3. And a negative over a negative is gonna be a positive. Is a positive bigger than 0? Yes. So you're gonna shade where your number was. We'll talk about that in a minute. So, the alternating thing works. We don't have any squares in there. So if that one is shaded, this one won't be, this one will be. This one won't be, this one will be. So we have 3 sections of answer this time. Now, Kyle says, shouldn't I color in those dots? And here's the first kind of tricky thing. This symbol would tell me to color in the dots. And I do color in the dots, but only the numerator dots. So the dots that came out of the numerator are gonna get colored. No dot in the denominator will ever be colored in. Because
It's like 1 over.
if you put a 2 in here, if you colored in that dot and put a 2 here, what would happen? A 0 in the bottom. And bottoms can't ever be 0. So make a note, star. Denominator dots always open. Denominator dots always open. No matter what symbol is in the problem, if the dot is coming out of the denominator, it will be open. So, these 2 came out of the denominator, so they're open. Negative infinity to negative 3. Negative 2 to 2. And 3 to infinity. Okay, how are we doing? Okay? Alright. Taking my sweater off here because this next one's a doozy. Do you notice anything different about problem number 10?
Doesn't got a 0 at the end.
Doesn't got a 0. And doesn't got a 0 is very bad news. So the first thing we're gonna do is give it a 0. So I am going to subtract 4 from both sides. I'm just gonna minus that 4 over.
Do you have to multiply anything into it?
Now, I have to get a common denominator.
Oh, you gotta
So,
multiply.
this denominator right now is a 1. This denominator is an x minus 3. So I am gonna give this guy an x minus 3. In an inequality, you're not allowed to drop the denominator. This problem is big because it's got a lot of exceptions to it. I have to keep the denominator, okay? As soon as I make a match, I gotta keep it. And then on the top, be careful, I have x plus 2, do your distributive, minus 4x plus 12. You're distributing negative 4. like terms up there, so we have negative 3x plus 14 over x minus 3 less than or equal to 0.
Yep.
Two dots on the number line. The one from the denominator is kind of easy. I know that denominator dot is going to be at 3. I have no idea where that numerator dot is. Look at that. That's a mess. Anybody remember what I told you the other day? If you can't eyeball it, like I can eyeball that and tell you it's a 3. I can't eyeball this one. What do I do when I can't eyeball it? No, that's not a quadratic. Yep, that's not an x squared. I set it equal to 0 and solve it. So negative 3x plus 14 equals 0. This is going to tell me where that dot is. So negative 3x equals negative 14, and x equals 14 thirds, which is 4 2/3. So I have my dot at 3, and now I have a dot at 4 2/3, or 14 thirds.
Doesn't matter which one you
What?
put. Do I have to put like 4 2/3 or can I just put 14?
14 thirds is fine. I put 4 2/3 so that you knew it was bigger than 3. All right. That dot's open, this dot's closed. Everybody good with that? Here comes the next exception. This is a tough problem. We're gonna do another one just like it. This is a tough one. There'll be one of these on your test. We'll review and fight through them. When I look at this sign in this problem right here, it is less than 0. What do I automatically think? I got 2 dots up here on my number line. What do I automatically think? Between them, right? Less than is usually between them. But when this happens,
Oh, the negative switches it.
the negative switches it. So when you end up with a negative out here in front, like that, instead of doing what you should do, you do the upside down or the backwards of it. So we should have been shading in the middle, but we're not going to. We're going to shade on the outsides. So we have talked a lot about when you put the negative in front of something that turns it upside down. This isn't really upside down, but it's like switching it. Instead of inside, it is outside. So my answer is negative infinity to 3, or 14 thirds, oops, that's a bracket, 14 thirds to infinity. That, you do not have an early dismissal in here. Yeah. I'm not supposed to let you go without a pass. Let me see if they put it in. Nope. All right, so let's try the next one. All right, who can remember the first step?
You gotta add a 0.
Get a 0 by subtracting 2 to the other side. So, do you ever pass, huh?
He's sending like a screenshot of it. So sent it
Who remembers what happens next? Mr. Hill?
You just do,
Common denominator.
You have to have a
you
common
times it
denominator.
by x minus one.
Yes,
Yeah.
very good, Zion. That 2 is automatically over a 1. We need it to be over x minus 1. So then I write 1 fraction. The denominator is x minus 1. 1 fraction, instead of 2, 1. Combining the numerators is gonna give me what? 3x plus 1
Minus 2x plus 2.
minus 2x. I can't read my writing, is that a minus? Yep, plus 2. Negative 2 times negative 1. So x plus 3 over x minus 1 when I collect like terms up there. Well, this one at least doesn't have the awful numbers in it. Can you tell where your dots are? You should have 1 dot from the top and 1 from the bottom. Can you tell where they are? One of them's at 1. Oops. One of them's at 1. And the other one is at negative 3. The symbol in the problem is just a greater than, so both the dots are gonna stay open. Furthermore, there's no negative. Now, I'm not talking about that negative, I'm talking about a negative out here in front. There's no negative out here in front. So that means I shade it just the way it's supposed to be. So where is a greater than supposed to be shaded?
Outside.
Outside. So this one's shaded outside. Negative infinity to negative 3. And 1 to infinity. We'll definitely practice some more of those. Check out at the front office. Okay? We're gonna do some word problems. Oh my gosh, look at word problem number 1. Have we ever seen anything like word problem number 1?
Yeah.
Yes, we have. What is our setup for a problem like word problem number 1?
Oh, it's like
Amount
I did this in high
times
school.
percent plus amount times percent equals amount times percent. Guys, in a little over a month, you're gonna be taking a semester exam. You better start remembering some of this stuff.
Oh yeah, we did this already.
Yeah, we did this already.
Yeah.
Yeah. So, here we go. How much? 12% needs to be added to 5 gallons of 15% to get a 14%. You'll recall, I hope, that every time we do one of these, we end up with 1 empty parentheses. Right?
Yep.
And we gotta fill that in. It's one or the other. Look, you're mixing x plus 5. Isn't this gonna be x plus 5 or 5 plus x?
Yeah.
When is it 5 minus x?
If it's a negative.
When it's here?
When the X is there? Or no,
When the opening is here, when the empty parentheses is there? All right, so here we go. We might need your calculators here. Failed start with your arithmetic. So I multiplied and distributed over there. And then what?
Add like terms.
Well, not really, I don't really want to add like terms, but move things around.
Yeah.
So I can subtract 0.12x. And that's gonna give me 0.02x. Again, you have a calculator, so there is absolutely no reason why you should be getting the wrong answer. So I got 2.5, what's my unit? 2.5 gallons? You remember that?
Yeah.
All right, let's do another one. Number 2. The setup is exactly the same. All right, so I have 54%. I have 84%, and I have 60%, and I have no idea what's going on back there. So there are my percentages all stuck in. Now this one's a little different. I don't ever had one like this before. 8 cups of 54, so doesn't the 8 go right there?
Yes.
Mixed with some 84%.
X.
X. And I'm gonna end up with a 60. So once again, isn't this just gonna be 8 plus X?
Yes.
Because I'm mixing these two together to get that one?
Yep.
So here we go. Same kind of equation I had a minute ago. I got 2 cups. I did some of that without a calculator though, so that's dangerous. You okay?
Yep.
All right, let's read question number 3. It is different. Question number 3. I don't think we haven't done them together. You may have done them in a different class. So read question number 3. Understand what's going on? We're not mixing lemonade and lemonade or something. We're not doing that. We got 2 people working on a job. When you have that kind of a situation, 2 people doing a job together, one option is to use this little formula. two people doing the job. 1 over the first person's time alone, plus 1 over the second person's time alone, will equal 1 over their time together. So, Gagnon's time is 4 hours. So I'm gonna start with 1 over 4. That's 1 over Gagnon. And then if Zach helps her, it takes them 3 hours. So what's the 3 hours? That's together. If Zach helps her, it takes them 3 hours. So this is 1 over 3. How long does it take Zach alone? So that's your X. Does that make sense to you? X is Zach alone. Now, if you look at that equation, how do we solve an equation like that that's full of fractions?
Multiply by X.
Make the denominators match.
That's what.
And what will be the common denominator? What do we need them to be?
12X.
12x. 12x. So this guy needs a 3x. This guy needs a 12. And this guy needs a 4x. Would you all agree with that?
Yes.
As soon as I make the denominators the same, I can ignore them. So I have 3x plus 12 equal to 4x.
Yep.
Subtracting 3x, it looks like x equals 12 hours. So it takes poor Zach 12 hours to do his homework.
It's a long time.
Now, those problems are pretty easy. Would you see if you can set up number 4? We have Grant and Matt painting the football field. Can you set this up using this little formula here? Take a minute and do that, and then I'm going to ask you for your ideas. Anybody want to volunteer an equation? Come on, birthday boy.
It'd be like.
Give it to us. What you got? Oh, you're gonna come up and, oh, okay, yeah, sure. Over here on this board. What is this? What is that? All right, let's see. Write down what you got. We're all gonna look right or not. Stand aside. This is the boys' equation.
Big common
You
denominator.
agree with that equation?
Yep.
Yep. So what do they do now? Get a common denominator. What common denominator could they use? There's more than one correct common denominator. What do you guys use?
48X.
24? Not just 24, it has to be 24.
Pardon this interruption, is Chase Nichols in the classroom?
He is.
Can you please send him to student services with his car key?
Oh, man.
Thank
Okay.
you.
Hurry up. Where did you park?
In a legal spot, for sure. It's definitely a legal spot.
Yep. Walk of shame.
Hurry up.
Kid thinks he's bigger than the car.
Quickly, you don't have much time.
Walk of shame.
Okay, wait. The common denominator isn't 24.
It's 48X.
No, it can be 48, but it has to have the
X.
X. 24 is okay, but you gotta have the X. So it's 24x. So 3x, top and bottom. And then 4x, top and bottom. And then 24, top and bottom. Now, if you want to use 48x, that is totally fine. Remember, we're dropping the denominators anyway, so it's fine if you want to use 48x. You will end up ultimately with the same answer as they did. Wait, why is that next there? It's 3 and 4. Yep. Now, we get a fractional answer. Did you get 24/7? Those of you that did 48, you got 48 out of over 14, but then you reduced that and got 24/7 hours. So that's a little bit more than 3 hours. So it takes them 3 hours and some to do it. So 24, good job, man. 24/7 hours. Good? All right, would you look down at number 3, down there that says Amelia? Do I have someone else who's willing to come up and put number 3 up on the board? The Amelia problem? Aaron? You willing to put it up on the board? All right, thank you. Quickly, we only have 4 minutes. Tomorrow, we're gonna do a little more, what do I see? All right, the day I see you was what, Thursday?
Yes.
We'll do a little more word problem review. There's a practice sheet in here, we'll do some more word problems. And a practice quiz, because then on Friday, we'll have a 2-problem word problem quiz. Guess what the 2 kinds of problems on the quiz will be? There'll be one like this, where Susie and Billy are doing a job.
Yeah, and then the amount and the
And then one where you are mixing solutions. Okay, we'll practice that again tomorrow, or next time, and then your quiz will be the time after that. We will also begin practicing, our practice test as 2-6, 2-7, 2-8. So we'll be having a test next week sometime. Okay? What time is football having to leave early tomorrow? Or Friday, I mean, I'm sorry. not Friday.
We are at 2:30? We're going after the last play.
So that's the last period, it's not going to be you guys. You guys will be there.
I think, no, we have a quiz on Friday, South Mid. We're reviewing them.
All right, let's take a look at what they got. They said 1/4 plus 1/x equals 1/1. Beautiful. Common denominator was 4x. X plus 4 equals 4. That's beautifully done. The only thing I might add is we need a unit on that. So that would be 4/3 hours. Other than that, it's splendid. All right, try to remember something by Thursday when we come back together.
Are we doing, new look at the packet or anything? Thursday?